Alright, so we end at lecture 1 looking at renewable, non-renewable resources and establishing the difference between environmentalism, environmental science, and then within environmental science, the difference between environmental science and environmental studies, and how both these things are considered interdisciplinary fields. So, to continue on with natural resources, we also have the resources that are in between those of renewable and non-renewable resources called, examples would be freshwater, forest products, agricultural crops, and soils. But ultimately, what would happen if we start to use these resources quicker than they could be replenished, then they too will become non-renewable resources. What we are seeing with the availability of fresh water on our planet, that is going to be one of the most scarce resources in the future. Actually, in some third world countries already, there are a lot of wars and people that die from not having available fresh water. So they are thirsty and dehydrated, and they can't get to a freshwater water hole, or their rivers or dams have run dry. We're also seeing that due to global climate change, we saw some really bad issues, scenarios during the summer of 2012, where certain areas were in such severe drought. At one point in certain spots, the Mississippi River, you could see the stream bed to the river in some locations where it would normally be several feet deep. So freshwater forest products, agricultural crops, when you strip the soils of their nutrients, then they can become non-renewable resources, just like fossil fuels such as crude oil, natural gas, coal, and then of course the metals that we would use. So ultimately, what do we want to do? We want to use our resources wisely so they can continue into the foreseeable future. And when we talk about resource use and using them wisely so that they are here for generations and generations of use, that would be sustainability. So we want to use them sustainably so they can be used by generations of the future. So when do we start seeing high consumption of resource use and the kind of environmental movement come about? We have to look at human population growth. So currently, our population on the planet is about 6.8 billion people. There are about 78 million people added to the planet each year, which averages out to about 200,000 people each day. So we look at the shift of how humans through time have changed and how society has changed. And this would be revolutions of humans. And the first part was the hunter-gatherer societies. And in a hunter-gatherer society, this is when people would go out and they'd harvest their crops, kind of like if you were to go out into the woods to find blackberries, raspberries, blueberries. You'd collect them, you'd bring them back to your village, and then you'd eat them and share with others for food. Or you'd go out and you'd hunt animals on the Great Plains. Now, there are still in existence today hunter-gatherer societies. And then about 10,000 years ago, humans began to live in villages. We saw longer lifespans and more surviving children. We started to see that transition from the hunter-gatherer lifestyle to a more agricultural way of life. We began to grow crops. We began to domesticate animals. And it was easier for humans to meet their nutritional needs. And because it was easier for us to meet our nutritional needs, so with this change in human society, we saw people started to live longer and produce more children. And actually, having more children was beneficial at this period of time, because then you'd have more people to go out and work in the fields, to plant the crops, to harvest the crops, to control the domesticated animals and feed them. So we started to see this, growing population of humans. And then about 300 years ago, in the 1700s, this is where we saw the change from the agricultural revolution into the industrial revolution. And we saw that shift from rural life to animal-powered agriculture, handmade manufacturing, and an urban-powered society that now was powered by fossil fuels, the oil, the coal, the natural gas. The Industrial Revolution, of course, brought about many improvements, especially in the areas of medical technology, sanitation, production increases due to fossil fuel-powered equipment and the chemical fertilizers. We saw infrastructure grow in cities, so we started to see cities develop, and we had new technological and scientific advances as well. This brought about the technologies like telephones, automobiles, computers. But with that Industrial Revolution, here is now where we really started to see a major human impact on the environment. So what is some of the problems of population growth? Well, there was a British economist, Thomas Malthus, and back in England, he wrote this essay in 1798 called An Essay on the Principle of the Population. And basically, Malthus claimed that unless the population growth was controlled, the number of people would outgrow the available food supply until starvation, war, or disease arose to reduce the population. Then again, more recent biologists from Stanford, you have Paul and Ann Ehrlich, and they warned that if the population growth will have disastrous effects on human welfare, and they published their findings in this book called The Population Bomb back in 1968. Now, fortunately, Ehrlich's forecast did not materialize on the scale he predicted, but some, such as economist Julian Simon, think that this dire prediction unlikely and maintain that technology can stretch our resources. But we look at the concern here still of how humans are using the resources, and we're starting to see some of these major issues come about today in our world. So what does this bring us to? How we use our food, how we use our resources, how we use our planet. This would be ecological footprints. So the total amount of land and water required refers to the ecological footprint. It's expressed as the environmental effects of an individual or a population in terms of the total amount of land or water to provide raw materials for an individual or a population to which they consume, and also to dispose of or recycle the waste an individual or population consumes. There are many footprints out there. You may have heard of your carbon footprint, so on and so forth. So it's most informative when footprints are calculated using the same method. So an interesting fact here is, by one calculation, the ecological footprint of an average American is about 3.5 times the global average. So think about all the products, all the resources that you use on a daily basis. And how, for example, if you woke up this morning, how your bowl of cereal with the milk, the cereal, the bowl, the spoon, your drink, the glass, all of that came about. What was required to manufacture those products? How did it get from Earth to you? That is kind of looking at your ecological footprint. So when we look at ecological footprints and we talk about resource use, there was a person at the University of California by the name of Garrett Hardin, and Hardin published this thing called The Tragedy of the Commons. And the Tragedy of the Commons basically describes a situation in which resources made available to everyone are used unsustainably. Now remember what that word sustainability means. And they eventually become depleted. We exhaust our resources. So he said that instead of having these common, unregulated resources, we need to implement some type of resource management, whether at a voluntary or mandated basis, to help prevent resource depletion. So in his time, what he referred to as the tragedy of the commons in his essay, the commons refers to public pasture land that was shared by villagers in the 19th century England. But we see this today, and there's still battles over certain resources, like, for example, ocean resources. Who has the availability of certain ocean resources so far from the terrain to which a ship can come out? So if you're talking about oil drilling, oil rigs in the ocean, or you're talking about fisheries, harvesting of kelp forest, just the resources and where that goes off the coast of the United States towards, if you're in England, how far off the coast you come from there. So we still have some of these issues with what is the common ground and how can we mandate them. A good example of that is if you ever watched Whale Wars and stuff like that. So the tragedy of commons, a modern day tragedy of the commons would be many parts of southern Africa are experiencing similar situations because vast forested regions have been cleared, deforested, to allow for farming and ranching. And because of improper techniques and the coupling of overuse of the land, basically the land dried up, was stripped of its nutrients, and it made it unsuitable for the very crops and animals that it was intended for. And in addition to that, these are some of the third world countries as well that experience an exhaustion of water, where people travel miles and miles and miles. Sometimes if they're ill or too young, they don't make it, just to find a fresh water hole. So this pretty much wraps up our first section of chapter 1, done in 2 lectures. And our next topic will be the nature of science, and we look at what science is, related a little bit more to the process of science and the scientific method for when scientists do research, and then how we use that data to make predictions into the foreseeable future, because that's often what environmental scientists do.